Section 2.6 is on higher order derivatives. So what are higher order derivatives? They're just second derivatives, third derivatives, fourth derivatives, or whatever derivative we want. So what is a second derivative? Well, it's just the derivative of the derivative. What's a third derivative? You just take the derivative 3 times. A fourth derivative, you just take the derivative 4 times. So it's nothing special here. It's just you might want to take the derivative more than once. So it might seem a little weird because if you think about the application, we have the derivative is the slope of the tangent line. So what would the derivative or the slope of the graph at the point or the rate of change at a point, right? Or we also actually have it as velocity as well. So we have lots of applications for the first derivative. So what the heck is the second derivative? Why would you care about a third derivative? Well, we're not going to get to third, fourth, fifth derivatives much in this class at all, but we absolutely, without a doubt, will be looking at the second derivative. So how is the rate of change changing? What is the rate of change of the rate of change would be that question. And we'll get to some applications later in this section. But the beginning of this section is really easy. There are no new derivative rules for you to learn. You're just going to find more than one derivative. So find the derivative and then the derivative of that and so on. So let's read through this together. It says second, third, and higher order derivatives. The standard derivative f prime is also often called the first derivative of f. The derivative of f prime is let me clear this up. The derivative of f prime. So the derivative of the derivative is called the second derivative and denoted by f double prime. So there's 2 primes there. So what is the derivative of the derivative? It's called the second derivative. And the derivative of the second derivative is called the third derivative. And we denote that by 3 primes. And then from there on out, it gets a little ridiculous with the prime notation. We're not going to sit there and put 4 primes, 5 primes. So what do? Anywhere from fourth on, you're going to see them put the number in the parentheses with that number there. And that just means how many derivatives do they want. Remember, there's not just f prime notation, there's y prime notation. You remember the dy dx? Well, it would be d squared y dx. So that's the derivative twice with respect to x twice. The derivative 3 times with respect to x 3 times. On all of those, that's what that notation means over there. Okay. So let's look at this. It says find the first 4 derivatives of f of x equals 6x cubed minus 2x squared plus 1. So let's go ahead and do this. Let's start off with the first derivative. If I did f prime of x, I don't know how much work you guys need. Hopefully you're really, really comfortable with your derivative rules at this point, that finding the derivative of this would be absolutely simple. So the derivative of 6x cubed would be drop the power, that would be 18x squared, minus 2x squared, drop the power would be minus 4x, derivative of 1 is 0. So the first derivative is 18x minus 4x. What would the second derivative then be? It's the derivative of that. So the derivative of 18x squared would be 18 times 2 is 36x. The derivative of negative 4x would be a negative 4. There's our second derivative right there. Let's move on to our third derivative. Our third derivative is the derivative of that. Well, the derivative of 36x is 36 times 1, which is just 36. And the derivative of negative 4 is 0. So that's it. That's all we have for the third derivative. Not really much work to show on this problem, is there? And then we move on to the fourth derivative. Again, the fourth derivative, anytime we do 4 or higher, we're just going to put the number in parentheses up there. What's the derivative of 36? Well, the derivative of 36 is 0. So there's the first 4 derivatives. Notice if I found any derivative from there on out, the 5th derivative, 6th derivative, 7th derivative, from there on out, it would be 0. So something I want you to notice, if you remember this, is called a polynomial function. If you think about it, no matter what that is on the polynomial function, if we took enough derivatives, if you notice every single time the power decreases by 1, that's what the power rule does, right? Drop it and then decrease the power by 1. So for instance, if it was a 15-degree polynomial, if you took 16 derivatives, you're guaranteed to be at 0, anything from 16 on. So at some point for every single polynomial, if you keep on taking derivatives, it would go to 0. That's not true for every function, though. Think about like e to the x. If we took multiple derivatives of e to the x, remember the derivative of e to the x is e to the x. So that would go on forever. Things like natural log of x. Well, the derivative of that is 1 over x. The derivative of that is negative 1 over x cubed. And it goes on and on and on, and that would go on forever. So that doesn't work for every type of functions, but it does work for polynomial functions. Eventually, if you take the derivative of enough derivatives of any polynomial function, you would get 0.